In this video, we're going to focus on creating those rotated labels here, but as you can see here, the moment we hit the halfway, we will start to rotate these labels basically an additional 180 degrees, so they are easy to read. As you can see here, the differences in there. So if I refresh this, you can see here, this will work nicely. So let's start, and the first thing we need is the border template, which you can find here on chartjs3.com, getting started. This link here, once you're on here, scroll down and copy this chunk of code and you're good to go. Next, if you want to get the source code of this video and many others, check out my Patreon page and of course, join the Discord channel. So, let's start to work on creating the polar area chart. First, we're going to say here, polar area, save that, remove the scales because we don't have any scales, or we don't have any Y scales to be exact. Save, refresh. There we are, that looks quite nice. So, what we need now is to create the shapes in here, and I'm going to say comma, and I'm going to say plugins, and I'm going to say here our segment text rotation cloud or something like that. It's a rotated cloud version, so we're going to say a constant equals ID, that one, and then we're going to say here when would we like to draw it, since the segments need to be drawn first before we put in the labels. So we're going to say here, after data sets has been drawn, we will draw our shapes and text. So we're going to say here chart arcs, there we are, we already have that, arcs and plugin options. So now what we're going to do here is an object destructuring. I think we will need the CTX. I'm not sure if we need anything else. Maybe just to be sure, let's put in here the data and say equals the chart object. So now we have this here, and what I want to do now is start to break that down in calculating the rotation here, because basically what I need is I need to know the center here from this angle and that angle, and then we're going to divide it by 2. That's basically what we're going to do here first. So to do this, I'm going to use here a built-in functionality that I'm going to show you right now. I'm going to say a chart get data set meta index 0, and then I'm going to say here dot data, for example, index 0. If I save this, refresh, we are getting now the arc element specifically for data point 0, which is basically the red one. And you can see here we have an end angle and we have a starting angle. And what I want to do is, this is the start, this is the end, and that's basically a pi version. So pi, 2 pi equals a full circle, 1 pi is a half circle. What I need here is basically the starting angle and the ending angle, and then deduct them from each other to get the right value. Or perhaps divide by 2, it's one or the other. I think it's adding them up together and then divided by 2, that makes the most sense. So what I'm going to say here, constant start angle equals chart, well, let's grab all of this, and then we say here dot starting angle, start angle, there we are. Then what I want to do is I want to get the same one for the end angle, there we are. And then finally, I need to calculate the difference. So the difference is basically adding these two together and then divide by 2. So we're going to say here center angle, that makes the most sense. And then we're going to say here, we will do here the start angle plus end angle, then divide by 2. But of course, this needs to get prioritized. So we prioritize the sum before we divide. Once we get that, we will get a console log. Let's see the value here. That should be any kind of value that we can start working with. Let's save that, refresh. There we are. It does calculate and do something, but 1.12 plus plus would be the value of index 0. So now we have calculated the center angle, and now it becomes easier to start drawing the item. So what we're going to do is let's start to draw one single item first. We're going to say ctx.save to indicate that we're going to draw something, so save all variables above. Then what I want to do here is well, let's start to get the coordinates. What I want to have is the coordinates here in the center of our segment. And what will be very interesting is we can use the built-in coordinates of the tooltip. There's a nice functionality that will grab basically the center of this. So what I'm going to say here is constant tooltip position, or POS, and then what I will say here, get the chart.get data set meta index 0 dot data, and then we're going to say here for data point index 0 or data point 0. And then what I want to do here is I want to get the tooltip position, which is a built-in functionality like this. Once we do this, I can do here console log again, get the tooltip position, save, refresh, and let's hide some of these console logs. We don't need these. Save, refresh. We're now getting the position, and the position is specified in a X and Y coordinate, which is perfect because now it becomes very easy to get the exact position here. So let's start to work on drawing the item. So what I'm going to do now is the following. I'm going to say here ctx.translate, and what I want to do now, instead of, because we're going to rotate later on, and this is very important. So what I want to do with the translation is I want to change our standard 0, 0 that will be here. I want to put the center here. That will be our translated item, and we're going to put in there the position of the X and Y coordinates. So that will mean that we will jump instantly here as the position of 0, 0. This is very useful for rotation, but I will talk about it later on. So we need here the X and Y coordinates, which is basically the tooltip dot X and then tooltip position dot Y. So once we did this, we can now start to draw something. So I'm going to draw something first so you can see a visual of this. ctx.begin path, because we want to create a shape that's independent of anything else. And then what I want to do here is I'm going to say here ctx.fill style, and the fill style will be based on our data, or specifically the border color here. So this data object gives us access to data here, so then we can go down to the border color. So what I'm going to say here, data.datasets index 0 dot border color, and then the index will be right now 0. Later on we can soft code that. So once we did this, the next thing what I want to do is I want to just put in some text here. So I say ctx dot, or I want to create a rounded shape. So I say here round rectangle, which is basically a rectangle where you can give a border radius. And in here I need the X, the Y, the width and the height, and the radius if ever. So right now I'll just put here the radius of 10. And then the X and Y will be basically these coordinates that we translated to 0. So this should be 0 and the Y is a 0. Then the width can be, let's make this 50 for now, and the height 20. Later on we can adjust that. Once we did this, what I want to do now is say ctx.fill to draw that specific shape. Save, refresh. Oh, here we are. You can see here what is happening is because of the translate, it will give us some weird response. So I need to make sure we restore it afterwards. So I say ctx.restore, save, and there we are. So as you can see here, we're getting the corner, but we're not really in the center yet. What I want to do is I want to move a little bit up and then more to the left side. To do that, it's quite simple because we have here the width, this is the width. So what I can say here, and I'm going to just make this a constant for now, because later on we'll be using that. So constant text width will be 50. Right now just hard code like that. Later on we're going to recalculate that. So we can say here, this width, that will be there. And what I want to do here is basically whatever is, if it is 50 here, that will mean I need to move it 25 pixels to the left. So what I'm going to say here, minus the width divided by 2. So since this is prioritized, it will calculate first. If I save this, refresh, there we are. So we could do the same for the height, we have the height of 20. So I'll just say here for this one minus 10 because that's half of 20. Save, refresh. Now we have that in the right position, but of course we need to rotate this as well. So we'll be doing that right now. So after the translate, what I'm going to do here is do rotation. So I say ctx.rotate, and for now all I need is the end angle. Later on we're going to fix that one. Alright, so as you can see here, the end angle is here, but it is doing something slightly weird. Let me check. And my bad, it is not the end angle. I am not focused. It should be the center angle, of course, because we want to be exactly in the center of the rotation. There we are. That looks phenomenal. So what we could do is we could loop through this immediately. So let's do that right now. So what I'm going to do here, all of these values here are very important. So we're going to move them here, and then we're going to say here data, or not even that, we can do chart.getDataSetMeta index 0 dot data, and then do a for each loop. We're going to loop through every one of them for each, and then we're going to say here data point, and then index function error expression. There we are. So once we did this, I want to copy everything including the restore, cut it and put it in there, give it a proper indentation here. Save, refresh. Alright, right now it's not yet correct because it's still hard coded here. Make this index, 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 and here we have index as well. Let's save that and see if that gets much better. There we are. That looks much better. So now what I want to do is I want to get these text, put it in here, but I want to make sure that they are rotated as well along with it. And well, we have most of this. So what you can say here is the following. I'm going to say here ctx.fill style, and let's give the font a white color because we have a colored background here, as you can see here. So the next thing what I want to do here then is to say ctx.fill text, and then we're going to see here what is the text. Well, we have here the text, we have here the X and Y position. Well, since we know and we already readjusted this to 0 because we have the translation, that will mean that this can be set on 0. And the text here, I'm going to extract the one from our labels here. So what I'm going to say here, the text will be data.data, no, not .dataset, my bad. It's labels and then the index. Why? Let's go up here. Data, labels, and get the matching index number. So there you are. Save, refresh. Right now we have this here. I'm not that happy yet. I want to align it to the center and afterwards recalculate the width of this as well. So what I'm going to do here is, first of all, I want to align it by, or give it a font type. So ctx.font, because right now it gets the default font, which is Arial 12 or 14 pixels or something like that. I want to make it bold. I want to make it 12 pixels, and I want to say sans serif as the font family. Let's save that, refresh, there we are. Let's align it now to the center because that should be better. So we're going to say here, enter ctx.fill, text, align, center, save, refresh. Alright, that looks much better, but now I need to make the space flexible. What we did here is calculating the item, and what I want to do is I want to measure the width of the text so we have the text width here correctly. However, to do that I need to move this font up because this defines the size of the font due to the bold font point and of course the font family style. So what I'm going to do here is we can say here we're going to grab this one here, but then I'm going to say ctx dot measure the text, and specifically I want to get the width of that. But what is the text I want to measure? This one here, and then I'm going to say it dot width because I want to get the width measurements in pixels. Let's go. We have that here, and that should work now nicely. If I refresh here, there we are, but this is far too tight as you can see here. So let's give it 20 or some pixels left and right, let's say plus 12 pixels. So we have 6 pixels on the left side and 6 pixels on the right side. Refresh there. Alright, that works. Now, if I have a long text, choose day long, save. There you are. It will recalculate nicely, but if you see these here, these are upside down, and we would like to recalculate the rotation for these. Since we calculate the rotation at the very center here of 0, 0 of each of these items, rotating will be very easy because we only have to rotate then the specific shape instead of everything. So what I'm going to do here, we're going to look at two things. Number one, we need to understand one thing here is, if we move this halfway here down, well, what we really need to do is not the moving it down, we need to understand how far of the rotation are we. And the number we're going to use is our center angle. So what we need is basically the center angle number. And we will measure if it's within this half of the slice, we can leave the position as it is. But if it's in the other half of the slice, we need to rotate this basically half as well. So let's start to look at how we can do this. Well, we need to know the numbers of it, and basically we can check the following. We're just going to say we know that 1 pi will be equal to a half circle. So that will be easy. However, there's one tricky part here. In the canvas, the pi or 0 starts here. So that will mean that a quarter of the pi here and a quarter of the pi up. So what I'm going to do here is only calculate one thing here. This one here, if we need to rotate it halfway, if we are passing this point here, from 0 to, if 1 pi is 3.14, that would mean that this here pi would be 1.57, somewhere like that. If you're not sure about that, well, we can calculate that right now by saying console log what is math.pi divided by 2. Let's look at that. What is the number? It's 1.57. So what we can do here now is calculate the center angle, which I'm going to copy here, put it in here, get the center angle, and see if we are in the right position. So we have here the item, and then if everything is farther than 1.57, it might need a rotation here. Well, what I can do here probably with an if statement to make it very easy, because it's quite tricky here. We're going to say here the if statement that will be based on the rotation, or if the center angle is bigger than math.pi divided by 2, because I only need the quarter segment to calculate. So then, if that is the case, I want to keep it like that. So let's see first if we have this. Save, refresh. Alright, that one works, but what we need here then is, I do see here the rotation is doing something. Alright. I guess this one here needs to be calculated. So let's say else, I'm going to cut out this, should be here. Let's save that, refresh. There we are. So this works. You can see here halfway here, and then here it understands that this has a different rotation position, or it's past that quarter of this segment here. So what I want to do here is rotate that in a different direction, or give it a additional pi, because 1 pi is a half circle, and I just need to rotate this 180 degrees. So that will mean here I want to say plus, I guess we can say plus the math.pi. Oh, are we correct? No, sorry. We have this one here, and then we're going to rotate this plus by, yes, that is it, plus 1 pi. By doing that, now as you can see here, it is changing. Let me just hide this, see if you can see the difference. Refresh. Alright. Or Let me just hide those so you can see the difference. So this is the standard. There we are. Look at the Friday. All of these are upside down. So now we're going to put that in there. And then we have this all nicely working and recalculate it like that. There we are. And that looks phenomenal. And that's it.